Good morning. Welcome to lecture 3 on water. In this lecture, we will study boiler problems due to hard water. In the previous lecture, I had very briefly explained you the different problems which are caused by hard water. Here we will study in detail the problems caused by hard water in boilers. Now there are basically four types of problems which are caused by hard water in boilers. First is scale and sludge formation. Second is boiler corrosion. Third is caustic embrittlement. And fourth is priming and foaming. Now we are going to study all these problems one by one. So I start with scale and sludge. Now what happens in hard water? You know that in hard water it contains lot of salts of calcium and magnesium. Now inside the boiler, steam is forming continuously. Now as steam is forming, what happens is that steam is removed and the concentration of water goes on increasing. So there comes a time when the concentration increases to such an extent that the salts begin to precipitate out. Now in the initial stages of formation of precipitate, it is soft, slimy and loose. So this soft, slimy and loose precipitate is called sludge. Now gradually what happens is that the precipitate begins to settle down, it becomes hard and it sticks firmly on the inner walls of the boiler. So when the precipitate becomes hard and when it adheres to the inner wall of the boiler, then in that case it is called the sludge. So basically the difference between scale and sludge is that if the precipitate is soft, slimy and loose, slimy means mucilaginous, then it is called a sludge. And if it is hard and it sticks to the walls of the boiler, then it is called a scale. So now we will study scale and sludge in detail. So sludges are they are formed by substances which have greater solubility in hot water than in cold water. So particularly we have magnesium sulfate, magnesium chloride, calcium carbonate. Calcium carbonate also forms soft scale or sludge. Sludges are generally formed in colder parts of the boiler and sludges can be prevented by blow down operation. Now this is a technical term. What is meant by blow down operation? See, in blow down operation what happens is that when lot of precipitate collects, like you must have seen when you keep on boiling water, then lot of precipitate, it becomes like, no, you can see lot of precipitate around. So what we do is we just remove that water and we introduce or we put fresh water in it. So that process is called blow down operation and it is one of the methods for removing sludges from boilers. Now we come to the formation. Now we have to study in detail the formation of scales and boilers, the removal of scales, and most important is the prevention of scale formation in boilers. So there are four things which are responsible for the formation of scales and boilers. First is the decomposition of calcium bicarbonate. So calcium bicarbonate on heating, it decomposes to form CaCO3 scale. So CaCO3 scale, it is a soft scale which is formed in high pressure boilers. Sorry, it is formed in low pressure boilers because in case of high pressure, when the pressure is high, then in that case CaCO3 is soluble in water. So it is formed in low pressure boilers. It is not formed in high pressure boilers. So one is the decomposition of calcium bicarbonate. Second is deposition of calcium sulfate. See, this is very important because calcium sulfate is soluble in cold water and as the water temperature increases, the solubility of calcium sulfate decreases. Now in case of boilers, the temperature is very high. So what happens is that calcium sulfate, which was originally soluble in cold water, precipitates out when the temperature increases. So calcium sulfate scales are formed. Now remember one thing, calcium sulfate scales are the worst kind of scales because they are the very hard scales. The third reason for the formation of scales in boilers is the hydrolysis of magnesium salts. So different magnesium salts which are present in water, particularly magnesium chloride, it reacts with water to form magnesium hydroxide. So a magnesium hydroxide scale is formed. Apart from this, calcium and magnesium silicates scale is also formed. So calcium and magnesium salts are present in water. Little bit sand or mud is also present in water. So calcium and magnesium salts reacts with the silica which is present in water, and it forms scales of calcium silicate CaSiO3 and magnesium silicate MgSiO3. Now we come to the difference between scales and sludges and boilers. We have already studied it. Here we are comparing it in tabular form. So sludges are soft, loose and slimy precipitates. Scales are hard deposits. Sludges are formed in colder parts of the boiler, and scales are formed in heated, there is a mistake here. This is actually sludge and this is scale. So we do the necessary correction. So sludges are actually soft, loose and slimy precipitates. Scales are hard deposits. Sludges are formed in colder parts of the boiler and scales are formed in hot portions of the boiler. Sludges are formed due to bicarbonates and carbonates of calcium, magnesium along with magnesium hydroxide, whereas scales, they are formed by calcium sulfates, calcium and magnesium silicates and so on. Sludges are non-adherent deposits. As you know, sludges, they remain floating in the water, whereas scales, they stick on the surface of the water and it is very difficult to remove the scales. Then sludges and scales both decrease the efficiency of the boiler, but however sludges are less dangerous and scales are very much dangerous because they also decrease the efficiency and they are very dangerous. Sludges are removed by blowdown operation. I have already explained you what a blowdown operation. When the concentration of salts in water increases, then we remove that water and we put fresh water inside the boiler. Sludges cannot be removed by blowdown operation. Now in the next slide you can see the diagram between scales and sludges. See, in sludges here you can see these are deposits like this. They are floating. I am drawing it in red. So they are floating deposits which are present in water. So these are sludges. Sludges remain floating in water, but scales, they deposit here. You can see these lined areas and they stick to the walls of the boiler. So this is the diagrammatic representation of scales and sludges in water. Now what are the disadvantages of scale formation of boiler? As you all know, there will be wastage of fuel because scales will stick to the surface of the boiler. Since they are poor conductors of heat, so you need to supply more heat to heat the water. So you are wasting energy. It lowers boiler safety because the scales, they stick to the boiler. So the boiler has to be overheated to maintain a steady supply of heat. So the boiler material becomes soft, lowering the boiler safety. It decreases efficiency. There is more input of energy and there is lesser output comparatively. So the efficiency of the boiler decreases and there is danger of explosion also, because if lot of scales will deposit, then the volume of boiler becomes less. If timely maintenance does not take place, then the pressure inside the boiler increases too much and it can lead to boiler explosion also. Besides the scales, they can choke the boiler tubes and all those things, so that also leads to boiler explosion. Now, once the scales are formed, how can you remove the scales? If the scales are loose, then in that case you can just take a steel scraper or a wire brush and you can remove the scales. Now scales can also be removed by thermal shocks. What is meant by thermal shocks? Those of you who are using a rod for heating water, you must have seen that white deposit develops on the rod if you are heating continuously. So what we do is we heat the substance or the rod to red hot and then we put it in cold water. So the scales which are present, they will break and they can be removed. So thermal shock means heating the boiler and then suddenly cooling with cold water. So the scales will break and they will be removed. Besides this, if the scales are very hard and adherent, then what we do is we do chemical treatment. We generally just say CaCO3 scales, they are removed by dissolving in 5 to 10% HCl, and calcium sulfate scales are removed by adding EDTA because it forms calcium EDTA complex, which is highly soluble in water. Now, what is our purpose? See, once the scales are formed, of course, we have to remove it, but in that case, you have to stop the whole process. Now, what we want that these scales should either not be formed, which is not possible, but at least we can delay the formation of scales inside the boilers. So that is called prevention of scale formation. So all of you know prevention is better than cure. So what we have to do, we have to prevent the formation of scales inside the boilers. So that is done in two ways. One is the external treatment. External treatment, as the name indicates, you are treating the water before putting it in the boiler. So this external treatment method, they are nothing but softening methods. So there are three methods: lime soda process, zeolite and ion exchange, which we will study later. For the time being, the most important is treating the water inside the boiler. See, because softening water requires specific techniques, increases the cost of the process. So what we do is we take hard water in the boiler and then we add certain chemicals so that scale formation in the boiler is delayed. So treatment of water inside the boiler, that is called internal treatment method. So there are two ways in which you can do it. One is by adopting some physical techniques and second is chemical techniques, that is by adding some chemicals. Now what are the physical methods? Now here one thing is very important. These internal treatment methods, they are also called conditioning methods and sequestration. So the question that you get in the exam, that is generally by the term conditioning methods. So the question is, discuss different conditioning methods used to prevent formation of scales and boilers. So this term conditioning is very important when it comes to prevention of scale formation inside the boilers. Now there are two types of techniques, as I told you earlier. One is physical methods. So there are three physical methods. One is electrical conditioning, colloidal conditioning and radioactive conditioning. Now in physical methods, what we do is we do something so that the scale forming particles do not come closer to one another and they do not settle to form scales. On the other hand, they remain in the form of sludges and they can be removed by blowdown operation. In chemical methods, what we do is hard scale forming particles are converted into softer particles which remain in the form of sludges. So there are four techniques. One is carbonate conditioning, phosphate conditioning, calgon conditioning and sodium meta-aluminate conditioning. So now first we will take up the physical methods. Remember, from examination point of view, physical methods are not very important. When you get a question in the exam, discuss various conditioning methods used to prevent formation of scale in boilers. You should write down the chemical methods only. If you write down physical methods, the examiner will not give you marks. But however, you should know the physical methods also. So physical methods, I will start from electrical conditioning. In electrical conditioning, what is done is electrodes are put inside the boiler and those electrodes, with the help of electricity, they are constantly shaken. So when the water is continuously shaken, the scale forming particles do not come in contact with each other. They do not settle down, and gradually when the concentration increases, you can remove it by blow down operation. Second is colloidal conditioning, in which what we do is we add some colloids like tannin, agar-agar gel, kerosene, etc. So they form a coating around the scale forming particles. Now these, all these, they are mucilaginous. So as a result, the scale forming particles, once again, they will not come very close to one another, and when they do not come in close to one another, they will remain in the form of sludges and you can remove it by blow down operation. Similar is the case for radioactive conditioning. We are adding some radioactive tablets. They emit out certain radiations which once again prevent the scale forming particles from coming close to one another, and once again what happens is that they remain in the form of sludges and they are removed by blow down operation. Now we come to the most important thing, that is carbonate conditioning. Now carbonate conditioning is used particularly when the boiler water contains calcium sulfate in it. Now when the boiler water contains calcium sulfate, as I told you earlier, calcium sulfate scales are very hard scales, and once they are formed it is very difficult to remove them. So what is done is Na2CO3 is added. So suppose the water contains calcium sulfate scales. So what we do is we add Na2CO3 so that it is converted into calcium carbonate and Na2SO4 is formed. Now these calcium sulfate scales, they are soluble in water in case of high pressure boilers, and in low pressure boilers they will precipitate out, but they are very soft scales which can easily be removed either by blowdown operation or by scrapping. The second method is phosphate conditioning. Now this happens both in low pressure boilers as well as high pressure boilers. So magnesium chloride, if the water contains magnesium chloride, then it will hydrolyze to form magnesium hydroxide scale. So what is done is we add phosphate, sodium phosphate to it. So we can add different types of sodium phosphate salts. So these are the three salts which can be added. So we add sodium phosphate so that it converts into magnesium phosphate, and this magnesium phosphate once again is loose sludge which can be removed by blowdown operation. Now which phosphate salt is to be used, that depends upon the pH of water and depends upon the other conditions. Now another method is Calgon conditioning. Calgon is nothing but sodium hexametaphosphate. So this is added to boiler water. So it converts calcium and magnesium into soluble complex salts which remain in soluble form in water, and scales are not formed inside the boiler. So you can see sodium hexametaphosphate is Na2, it is a complex salt. So it is Na2Na4PO3 whole 6. Now when this ionize, it will ionize like this, 2Na positive, and the complex anion will remain as such. Now when calcium sulfate or magnesium salts which are present in water, then they will replace this sodium from the secondary valency and it will form a soluble complex Ca2PO3 whole 6. And then when this is formed, it will combine with sodium salts ions present in water and it will form a soluble complex. So all the calcium and magnesium salts which were present in water, they will get converted into a complex salt. Now even if this ionizes, how this will ionize? This will give you twice, this will ionize like this. So once again you can see that calcium ions are not available, freely available. They are in the form of a complex ion. So once again they will not deposit, they will remain in soluble form. When the concentration increases, then in that case it forms sludge which can be removed by blow down operation. Then prevention of scale formation, the last method is sodium meta-aluminate conditioning. So sodium meta-aluminate, this will hydrolyze to form NaOH and AlOH whole thrice. So AlOH whole thrice is a gelatinous precipitate. So it will remain as in a gelatinous form, and whatever salts which are formed like magnesium chloride, suppose it is present in water, it will react with this NaOH and it will form magnesium hydroxide. Now since aluminium hydroxide is mucilaginous or gelatinous, so it will encircle magnesium hydroxide and it will stop it from forming a scale, and it will remain in the form of sludge as a loose precipitate, and it can be removed by blowdown operation. So these are the 4 conditioning methods which are used to prevent the formation of scales and boilers. So let us very quickly revise them. The first one was carbonate conditioning, which is used when calcium sulfate is present in water. Then phosphate conditioning, it is used when magnesium salts are present in water. Then Calgon conditioning can be used when calcium and magnesium salts of any kind are present in water. And last is illuminate conditioning. So this is all about the prevention of scales and boilers, and this is very, very important from examination point of view, and you get a question on this almost every year. Now we come to another boiler problem, that is boiler corrosion. See, all of you know what is corrosion. Corrosion means the decay and disintegration of metal surface. So when we are saying boiler corrosion, it means the decay and disintegration of boiler material by chemical or electrochemical attack with its environment. Now there are three reasons why boiler corrosion occurs. First is acid formation by dissolved salts. Second is dissolved carbon dioxide, which is present in water or which is formed due to salts which are present in hard water. And third is due to dissolved oxygen. So the first two are due to hard water, due to salts in hard water, and the third is oxygen is actually what oxygen is always present in water. So let us take them one by one. So first is acid formation by dissolved salts. See, suppose magnesium chloride is present in water. So this will react with water at naturally the temperature and pressure is very high because we are talking about boiler. So magnesium hydroxide precipitate is formed and acid is formed. Now this acid will react with boiler material, which is iron, and it will form ferrous chloride and hydrogen is formed. This ferrous chloride then gets hydrolyzed. Ferric hydroxide is formed. This is a precipitate. So the arrow will be pointing downwards and HCl is formed. So you can see here that even if small quantity of magnesium chloride is formed, it will form little bit acid, but after that a chain reaction is initiated and lot of acid will be formed. So this acid formation by dissolved salts causes extensive boiler corrosion because these steps 1 and 2, they are repeated again and again. Now after this ferrous hydroxide gets oxidized to form ferric hydroxide. This is nothing but rust. Now the thing is that one more thing is important, and that is important. How can you control boiler corrosion due to acid formation? So since this acid is formed, what we do is we add how can you prevent boiler corrosion due to acid formation? That is by adding calculated quantity of base. So base generally added here is NaOH. So what we do is we know first we calculate how much magnesium chloride is present. From that we calculate how much HCl will be formed, and then we will calculate how much NaOH will be required for its neutralization. So we are adding calculated quantity of base, and this is used to prevent boiler corrosion by acid formation. Now we come to boiler corrosion by dissolved carbon dioxide. So first thing is, how does carbon dioxide come in water? That is by the decomposition of bicarbonates. So when bicarbonates are present in water, they will decompose to form carbon dioxide. You can see the equations, and these equations we have studied a large number of times. Now this carbon dioxide will react with water to form carbonic acid, which is a weak acid, but this carbonic acid will react with iron of boiler material and will form FeCO3, which once again is an unwanted product and leads to boiler corrosion. So since this is a weak acid, this boiler corrosion will be a slow process. Now how you can prevent boiler corrosion due to carbon dioxide? For that, since this is a weak acid, we add a weak base, that is ammonium hydroxide. So it will react with carbon dioxide and you get ammonium carbonate, and this is neutral. So this will remove the carbon dioxide and boiler corrosion will be prevented. Now the last reason for boiler corrosion is dissolved oxygen. So oxygen is naturally present in water. So oxygen in the presence of moisture, water which is present in the boiler, and iron reacts to form ferrous hydroxide, which oxidizes to give you rust. Now how you can prevent it? That is by removal of oxygen from water. So that can be done by two ways. First is by adding chemicals, like you add hydrazine. This chemical is actually hydrazine. So when you add hydrazine, it will combine with oxygen to form nitrogen and water. So this is actually the best method to prevent formation of scales. This is the best method to remove oxygen. So because both nitrogen and water, they are harmless, cause no problem. Another is you can add sodium sulfite, so that will remove oxygen. Sodium sulfate is formed, or you can add Na2S, sodium sulfide, that once again Na2SO4 is formed. But by both these methods, sodium salts are introduced in water. But by this method, nothing is introduced in water, and this is best because nitrogen is inert, causes no problem. So this is the best method to remove oxygen from water. Another technique is by mechanical de-aeration. So you can spray water on preheated plates. So as a result, when the temperature increases, the solubility of gas and water decreases. So the oxygen will escape out and oxygen will be removed from water. So in short, let me repeat, boiler corrosion is caused by three problems. One is due to dissolved acids in water, which come due to hydrolysis of salts in water. So to remove boiler corrosion due to acids, you add calculated quantity of base, which is NaOH. Second is boiler corrosion is due to carbon dioxide. So to remove carbon dioxide, what we do, carbon dioxide comes by the decomposition of bicarbonates, and to remove it we add ammonium hydroxide. And the last reason is due to dissolved oxygen, which is naturally present in water, and to remove it or to prevent boiler corrosion due to oxygen, what we do is we can add hydrazine, we can add Na2SO3, we can add Na2S. Now we come to the third boiler problem due to hard water, that is priming and foaming. So priming is nothing but the formation of hot steam. Wet steam, sorry. When water droplets are carried along with steam, then we call it wet steam, and this formation of wet steam is called priming. So why does priming occur? That is due to very high velocity of steam formation. Second, suppose you are removing steam at a very rapid rate, then in that case the boiler, to maintain the pressure, it will start forming steam rapidly, and in that case water droplets will be carried by it. Second reason is hardness of water, that is when dissolved solids or impurities are present in water. Third is sudden change in boiling. Fourth is faulty boiler design. Now how can you minimize priming? First is by rapid control, by taking out steam at a constant rate. So when you take out steam at a constant rate, in that case we can minimize priming. Boiler design should be proper. You can add anti-priming plates or dash plates. So when steam comes in contact with these plates, then it condenses and falls back inside the boiler. We maintain low water level. So when you maintain a low water level, then in that case priming can be avoided. Then use of water without suspended impurities, and you have to remove scales from time to time. Now what will be the disadvantages of priming in boilers? So whenever there is priming in boilers, what happens? Water droplets is carried along with boilers. So when water droplets are carried, then some salts are also carried along with it. So these salts, they go and deposit in the cooler parts of the boiler. So they choke the tubes and they lead to some secondary problems. So when they fall on the blades of the turbine, then they cause corrosion of the turbine blades. Therefore, it is very important that priming should be minimized. And I have already told you what are the ways in which you can minimize priming. Second problem is foaming. Foaming means the formation of persistent foam or bubbles which do not break easily. Actually, priming, foaming and steam which carries salts with it, that is called carryover. So priming, foaming and carryover, they are three problems which are interconnected. So what are the causes of foaming? It is due to the presence of oils or alkalis in boiler which reduces surface tension. And how can you minimize foaming? by adding some anti-foaming agents like castor oil or silicic acid, or by adding some compounds like sodium aluminate, aluminium sulfate, which removes oil from boiler. So this is how we can control foaming in boilers. There is another problem which is carryover. Carryover means when the water droplets, they carry salts with it, that is called carryover. So when priming is prevented, foaming is prevented, then automatically this problem carryover will also be prevented. Now we come to the last problem which is caused by hard water in boilers, and that is caustic embrittlement. Caustic embrittlement. See, all of you know what is brittle. Brittle means something which breaks easily. So when there is excessive alkali in boiler water and the boiler material becomes brittle due to excessive alkali, then it is called caustic embrittlement. Now, how does this base come in the boiler? So that is because when you are using NaOH to soften water, Na2CO3, then this Na2CO3 gets decomposed to form NaOH. Now, how does this NaOH cause boiler corrosion? It causes boiler corrosion in two ways. First is NaOH reacts directly with iron of the boiler to form sodium ferroate, and the second is that it forms concentration cells. So due to formation of concentration cell, also boiler corrosion occurs. Actually, caustic embrittlement occurs mainly due to this second reason. So let us see direct attack. So when NaOH attacks directly, then salts like sodium ferroate, Na2FeO2, and small amount of sodium ferrite, NaFeO2 is formed. So the equations are written here. See, iron will react with NaOH to form sodium ferroate. This sodium ferroate will hydrolyze to form NaOH. Sodium ferroate once again oxidizes to form Fe3O4, and this Fe3O4 reacts with NaOH to form sodium ferrite and ferroate. So these are the equations which lead to boiler corrosion when NaOH reacts directly with iron. So you can see here that NaOH is constantly being formed and the concentration of NaOH goes on increasing, leading to more and more corrosion. Now the second or the more important reason which leads to boiler caustic embrittlement is that, see, NaOH is formed inside the boiler due to hydrolysis of Na2CO3. Now this NaOH by capillary action, see, scales have deposited on the sides of the boilers. There may be areas which are bent, there may be areas which are riveted. So due to capillary action, this NaOH will penetrate the cracks and crevices inside the boiler. Now when this NaOH comes in contact with the boiler, then the water evaporates because the temperature is high and the concentration of NaOH goes on increasing. So now you have two concentrations of NaOH. In these areas, cracks and crevices, the concentration of NaOH is high. And in the plain areas, the concentration of NaOH is less. So a concentration cell is formed where iron, which is in contact with concentrated NaOH, behaves as anode, and iron, which is in contact with dilute NaOH, behaves as cathode. So a cell will be formed, and as you all know very well that oxidation occurs at the anode. So iron, which is in contact with concentrated NaOH, it will get oxidized and it will keep on dissolving. So in these areas, the iron will become, since it will keep on dissolving, so these areas will gradually become thinner and thinner and thinner, and they will become brittle. So that is why we call it caustic embrittlement. Now, how can you prevent the formation of caustic embrittlement? So it can be prevented first by adding tannin or lignin to boiler water. So these tannins and lignins, they will block those crevices and they will stop NaOH from penetrating inside. Hence, two concentrations will not be created, and hence concentration cell will not be formed. Second is by adding Na2SO4 to boiler water. So this Na2SO4 also blocks the hair cracks. So once again the ratio should be either 1:1 or 2:1 or 3:1 for boilers which work at these pressures. If it is working at 10, then the ratio should be 1:1. If it is working at 20 pressure, then 2:1. If it is working at above 20 atmospheric pressure, then the ratio should be 3:1. Third, how you can control is by using sodium phosphate instead of sodium carbonate for softening water. Fourth is by keeping the pH of boiler water between 8 and 9. And fifth is by avoiding excess use of Na2CO3 in lime soda process. So this is all about the boiler problems due to hard water. We have studied how those problems arise due to presence of hard water, like what are the reactions which lead to those problems. We have studied what will be the bad effect, what will be the problem caused in boiler due to that particular problem. And we have also studied the prevention, how you can prevent that problem due to hard water. So all the four problems we have studied in detail, and that is all for this lecture. So this is the reference book that I have referred to. This is the back cover of the book. This is the links by which I will give these links in the description box also. So you can check on this book and you can go through it. So that is all for this lecture. Thank you all. Thank you, students.